Okay, who needs a fast refresher on exponent laws? I'm guessing you, if you're watching this video. Okay, so let's just go through them fast. So we got our multiplication law. So if you have two things with the same base, you can add their exponents. So x to the 5. If they're being multiplied by each other. If they're not, if it's like x cubed plus x squared, it equals x cubed plus x squared. You can't do anything with that. So it has to be multiplied by each other. Also, it has to be the same base. If you have x squared, y cubed, yeah, no, it stays like that. So it has to be the same base. They have to be being multiplied together. Then you can add their exponents. So that is our law for multiplication. Okay, let's talk division. Division. So if you have x to the 10 divided by x to the 4, you can subtract your exponents. So it'll be x to the 6, x to the power of 6. They have the same base and they're being divided. Cool. If you have x to the power of 10 minus x to the power of 4, can't do anything. They're not being divided. They're being subtracted, and we don't have a law for that. And they have to be the same base. Ooh, you can even add some numbers in here. So like say, I don't know why, but numbers seem to trick everyone. Say we have 10x to the power of 7 divided by 4x to the power of 2. Okay, 10 and 4 are still numbers. They're not exponents. So treat them like numbers. How would you treat 10 over 4 in like regularly? You would probably simplify it to lowest terms. So you'd probably make it 5 over 2 if it were just a regular fraction. So let's make it 5 over 2. And then why don't we still use our exponent laws for this guy? So 7 take away 2 would be 5. So x to the power of 5. Cool. And you can write it like 5 over 2 times x to the power of 5. You could write it like that. You can put the x on the numerator, because technically it is, because that's kind of like it's over 1, right? Okay. Let's talk negative exponents. No. Yeah, let's do it. Okay, let's take it from the division standpoint. So let's say we had x to the power of 6 divided by x to the power of 10. Okay, we've got more x's on the denominator. So when you subtract your exponents, you're going to end up with a negative number. That should happen, right? Because if you think about it, that's like, I wish I did a smaller number. Okay, that's like 6 x's on the top, and then you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the bottom. So if you're simplifying this and you're like, okay, I'm going to cancel those 6 out with these 6. I don't even know if I did. 1, 2, 3, 4. That leaves you with 4 x's in the denominator. In the denominator, people. That's why when you have a negative exponent, it seems like it's crazy that you would just flip it and put it positive on the bottom. But that's why. It does actually make sense. So those x's are actually in the denominator. So if you see a negative exponent like that, we don't like it. We don't want a negative exponent to be left like that. So we want to do this. Put it in the denominator. Or take the reciprocal, I guess. So you're flipping it. Okay, let's say you got some positives and some negatives. So let's say you're just working on simplifying expressions. So let's say you had x to the power of negative 5, y to the power of 2. Okay, y is cool. It's got a positive exponent, but x doesn't. So if you want to make it positive, you're going to go 1 over x to the power of 5, but that y is going to stay in the numerator. It's over 1. It's on top. And then if you want to combine those, you could. 1 times y squared is just y squared. X to the power of 5 times 1 is just x to the power of 5. So that looks a lot nicer than having them separate. What else? Okay, let's say you have a fraction. Let's say you have like 2 over 5 to the power of negative 3. Okay, so long way. You know what? Let's just move that down here. We need some space. Okay, I'll show you the long way. The right way. Okay, so we're going to do the same thing. Like, it's like this is over 1, so we're going to flip it. We're going to make it 1 over 2 over 5 to the power of now positive 3. Awesome. But who wants that? Who wants like a number divided by a fraction? I don't think anyone. So we can make it look a little better because we know when we divide fractions, like if you have, this is just a little aside here, if you have 1 divided by 2 over 3, I don't know why I'm using different numbers. You can change this division sign to multiplication. So you can say 1 times, and then you flip the second fraction, 3 over 2. I feel like we learned how to divide fractions like way back a long time ago, and then we don't really do it a lot. Right, so just like another example in case you want one. Let's say you have 2 over 3 divided by 4 over 5. The way we solve that is we do 2 over 3 times 5 over 4. So we always switch it to a multiplication sign and flip the second fraction. So you're gonna do that here too. This division sign, it's gonna become a multiplication sign, and we're gonna flip 5 over 2. And it's still cubed. So then I would just simplify it. 5 times 5 times 5, what is that, like 125, I'm guessing? And then 2 cubed, 8. And then if I multiply that by 1, it's just 125 over 8. Whew. Or you can see what happened, like shortcut. This actually just flipped, right? It just became 5 over 2 to the power of 3, shortcut. Okay, so that's negative exponents. And that's like, even if you had 2 to the power of negative 3, it's not like that equals negative 8. It doesn't. Ask your calculator. It equals 1 over 2 to the power of 3, so it actually equals 1 over 8. Okay, just emphasizing the negative exponent thing. All right, we also got power of a power. So if you have like 2, no, let's not start with that. If you have like x squared to the power of 3. So if you have 2 exponents like that, that's called a power of a power. And it turns out we can just multiply those. We can just make it x to the 6. That makes sense because it's like we have x squared written out 3 times. X squared times x squared times x squared. That's what the exponent 3 means. And now it's like you're just using the multiplication law. 2 plus 2 plus 2 is 6. So that makes sense. And even if you have a number in here, like 2x squared to the power of 3. Everybody forgets about this guy. But like he has an exponent too, or she, or they. They have an exponent 1, and you have to multiply that exponent 1 by the 3. So 2 to the power of 3, x to the power of 6. And then you can simplify them. So 2 to the power of 3 is 8, and x to the power of 6. So don't forget about these guys. They're numbers, like they're included in the exponent power of a power thing. Okay. I think that's it. Oh, and I guess just the old anything to the power of 0 equals 1. Don't forget about that. Even x to the power of 0, that equals 1. Because anything to the power of 0 equals 1. That's all I got.